Hi guys, welcome back to my channel. In this video, I'll be taking you through the volume of a solid and particularly the Dix method. So you have several ways of finding the volume of a solid using integration. So in this problem, I'm going to take you through the Dix method. The Dix method. So under the Dix method, how do you go about it, or what's the computation? Now, when you say volume, you know that volume is just the space occupied by what, a three-dimensional figure, right? So if I draw any axis, my x and y axis, a volume of a solid figure will be created provided there is revolution, right? So when you are using the Dix method, the only condition that should be taken note of is that you should have a function which is in contact with an axis, being its x-axis or being its y-axis, right? So if you have any function which is against the x-axis or y-axis, that particular function can be revolved around that axis to create a volume. So assuming that you are having this query here, a function which is in this form, right? Once I revolve this, I'm going to have something like cylinder, right? A mini cylinder with a very short distance. Okay, so it forms something like a Dix, something like a Dix. So that's why we are calling it the Dix method. Okay, so whenever you are being given a problem, just take care of some of the important parameters in the problem. So if it happens that your problem is saying that you have a function against what, the x-axis or the y-axis, or you take that the region bounded by that particular curve and the x-axis. So once you hear something like that, you realize that upon revolution, it's going to create a solid figure, and that will look like what, a cylinder. And what is the volume of a cylinder? Volume of a cylinder generally is equal to pi r squared h. Is that not it? Pi r squared h. So it's the same application you are going to use here. But now in this case, pi is a constant, so to be maintained. But what is our radius? Remember, our radius is going to act as what? Our function. Our function is going to be the radius of what? Of our solid figure. Then the height here will be the change in x or change in what? Y, depending on what? The axis. Because the height will be what? Just a short height that will be from here to here, right? From here to here. So, or if it's along the y-axis, the height will also be what? A change in y or a change in x. Okay. So once you have got this, you just come to, so this is the general formula I've written here. So generally, using the Dix method to find the volume of any solid figure upon revolution is equal to pi out, because the constant, integral from a to b, that is the point, or the point of what, your origin, I mean the boundaries, okay? Then the function squared, and that is what I said is acting as a radius, dx as your height. That is all. That is. So upon knowing this, let me give you a problem so that you know exactly how this is applied when you are solving problems. Okay. So find the volume. Find the volume of the solid formed by revolving the region bounded by the graph. So by revolving the region bounded by the graph, f of x equal to square root of sine x, square root of sine x, and the x-axis, and the x-axis, okay, where x is a member of the set or the interval 0 to pi, interval 0 to pi, about the x-axis. So let's analyze the problem. It says find the volume of the solid form by revolving the region bounded by the graph f of x is equal to square root of sine x and the x-axis, where we have our boundaries to be 0 towards pi. So this should tell you that we are having the region as just function and the x-axis. So seeing this x-axis should give you the nature of what, of our problem. And you clearly see that it will be a Dix, right? So if you know sinusoidal waves, so let's take this a half wave. that will be something like a semicircle against the x-axis, right? You realize that upon revolution, it's going to create a solid figure, and that's going to be what? A cylindrical form, right? A cylindrical form of height being the change in what? X here. That will be the height of that solid figure, right? Then also the radius is going to be the function, because we know that x-axis is x-axis, right? So you have the function being this. So originally the radius is simply what? The function itself, right? So you just make substitution into this formula. So from here, you know that our volume will be equal to pi out integral from 0 to pi of the expression our function square root of sine x all squared, then the x, because we are dealing with what? The x-axis. As simple as that, right? As simple as that. So performing this simple integral, you're supposed to what? Find your volume. And now when I simplify this, I'll simply have integral 0 to pi. The square root of sine x, when I square it, so cancel the square root out, and I'm going to have sine x, okay. So with this, if I integrate sine x, I'm going to get what? Negative cos x, right? So I'll have pi out negative cos x. Then I'll introduce my limit 0 to